Hello, my name is Casper Laursen, and I'm working with SIGIS, the Danish Agriculture and Food Council in Denmark. And today I will present to you the results from organic field trials on digestate and other recycled fertilizers in spring barley. It's field trials that we performed with support from Organic Plus project in 2019 and 2020. Yeah. So just need to like that. Okay, so this is really what it's all about, this presentation. It's about recycling, the return of nutrients from the city. So this is a good old organic principle that is illustrated here by, on the right hand side, the collection of food waste or household waste. I'm sorry for the Danish text. Hope you can live with that. And this household waste is used for biogas production. And the residue from the gas production is returned to the agriculture as fertilizer, which then produces new high-quality organic products for people in the city. So this is what it's all about. And I think we'll just put it up in the corner here in order to not forget, and move on to the agenda. Yeah, first of all, I will touch upon organic agriculture in Denmark in general and our dependency of organic slurry. And then afterwards, the field trials, which products are tested, what are the value of the fertilizers, and in the end, a little bit about the levels of heavy metals and some of the contaminants in the fertilizer products. So first of all, in organic agriculture in Denmark, we are fertilizing the soil to a suboptimal level. And it makes us inefficient and non-climate friendly, at least less climate friendly compared to what we want to be, what our ambitions are. But this all starts with a positive problem, really. The organic agricultural area is quickly rising in Denmark, and you can see that on the figure. And we now covers around 12% of the agricultural landscape, which is approximately 300,000 hectares. But the distribution of livestock are unequally divided between the eastern and the western part of Denmark. And though it's a very small country compared to other European countries, at least, it makes the distribution of organic fertilizer difficult. So organic farmers often use or tend to use conventional manure. And here you can see the distribution of livestock productions and plant productions in Denmark. The blue dots are the livestocks, and they are primarily in the western part of the country. And the green ones are the plant productions. So you can see that in the eastern part of the country, we have almost no organic livestock production. Yeah, which is a problem, I think. So of course, these organic plant producers are they're all trying to use green manure and nitrogen fixing plants and etc. But they are still largely dependent on conventional manure. And it's allowed in Denmark to use that to a certain extent. But are there any additional solutions to this problem? This is where the idea of recycling household waste in these biogas plants comes in. It seems to have the potential to make organic agriculture more independent of conventional manure, and maybe it can even make the production more climate friendly, which would be a good plus. So on to the field trials. I will show you results from the 2019 field trials and tell you about the 2020 results, as they're not published yet and not completely verified. Yeah, but we're making a lot of scientific tests, and here it is on recycled fertilizers. And we've done this on 5 very different locations in Denmark in both 2019 and 2020. And the field trials are performed on regular agricultural spring barley fields, as the one you can see in the picture. So it's not areas normally used for scientific testing. It's just regular real-life spring barley fields. And we're going with 4 repetitions, and trained professional field trial workers are doing the field work and the registrations. And then the farmer himself or herself is doing the sowing and the weed management as in the rest of the field. So which products are contained in this field trial? First of all, we're using conventional manure because that's what we're used to. That's our reference. The other products are compared to this product. And then we have a product called Øgro 1031, which is pelleted meat and bone meal. It's a well-working and easy to use fertilizer, but it is rather expensive. And then we have 3 different products containing household waste of some kind. The first one is a mixture with manure, which is how it often works in biogas plants in Denmark. We have around 12.5% household waste, and the rest is manure. And then we have 2 products containing nothing but household waste. The first one is Danish, and the one at the bottom is a German product. So these products containing 100% household waste, we haven't seen anything like this before in Denmark. I know it exists in other European countries though, so maybe you know more about this than I do. So about the application of these products, slurry and household waste, they are applied in the soil before sowing, and Øgro is applied on the soil and then harrowed down afterwards, but it's also before the sowing. And we are addressing nutrient content, fertilizer value, the levels of heavy metals, and then something about the contaminants or the physical impurities, you can say, among others, plastic. Yeah. And this is how it looks like on the left side of the screen, the picture of the photo, the digestate from household waste. It looks exactly like slurry. And it has the similar consistency. The method of application and machinery and everything is the same. Even the nutrient content, as you can see from the table, is kind of alike. You can have a look at the content afterwards if you're interested. I will not go much into it. Just say that it is within the same range as the manure that we usually use. Yeah, so we will just hurry on to the fertilizer value. So on the horizontal axis, we have applied ammonium nitrogen, and on the vertical axis is the yield. So firstly, we will have the slurry. It behaves exactly as we expect, which is good. So we have a rising yield as a function of the applied ammonium nitrogen to a certain point, and after that it stagnates and maybe even declines a little. Yeah, so we have a significant increase in yield per kilo applied ammonium until 80 kilo ammonium nitrogen per hectare, which is what we expect. Then we add the first of the recycled products. This is the meat and bone meal product called Øgro 1031. It actually contains no ammonium nitrogen at all. So the ammonium nitrogen is approximated from a nitrogen utilization of 70%. So it's an assumption. And the yields tend to be a little lower than from normal slurry. Øgro is very sensitive to very moist soils or very dry soils. So we seem to maybe have hit one of the years. The yield is only significant different from slurry with the application of this 80 kilograms of ammonium nitrogen per hectare. and only on the clay soils. If we include sandy soils also, we'll have no significant difference between these two products. And we also add these red dots. It's the mixture of household waste and slurry that you saw on the last slide. And there's no, as you can see, significant difference between these two products, the slurry and where there are mixed in a little bit of household waste. So the result here can maybe be that we can say that that we can include household waste in the biogas production without reducing the value of the fertilizer, at least in 2019 and in spring barley. And now we added two more dots, the green one and the yellow one, as you can see. And these are the products from 100% household waste. And the utilization rate here is equal to the one of pig slurry. And it's across all the localities of the field trials. Yeah. So that was the fertilizer value. We'll move on to the heavy metals. Yeah, so this is just to show you that in relation to heavy metals, digestate from household waste is much better and much cleaner product than regular pig slurry, especially when it comes to copper and zinc, where the levels are 8-9 times higher or something in zinc and in copper. And we'll move on to plastic. On the left-hand side, the photo here, it is a plastic from a sample of 1 liter of digestate from household wastes that we used in the field trials. So it contains plastic. The table over here shows the allowed levels of contaminants or these physical impurities when applying equivalent to 80 kilos of ammonium nitrogen per hectare. And then the actual level of these contaminants, all bigger than 2 millimeters, that is what we can detect for this Varga products, one of those products containing digestate from 100% household waste. So here I want you to pay attention to the second line especially, where we in Denmark have a threshold for maximum allowed plastic per hectare in area covered. The maximum allowed is 1 square centimeter per percent dry matter measured in 1 liter of pulp. Pulp is the input to the biogas plant. Here, when applying these 80 kilos of ammonium nitrogen per hectare, the digestate is well below this threshold, which is more than 8.5 square meter per hectare. But it is still almost, if everything is every little piece of plastic is put side by side on the top of the soil, it is still approximately or almost 3 square meters completely covered in plastic on top of the soil. It still seems like a lot to me, at least. And also I presented this to a lot of farmers, and they're not fun with the idea of deliberately or intentionally applying plastic to their agricultural soil. So we need to do better here. And then on to the 2020 field trials. Digestate from household waste in mixture with slurry is in the field trial again, and we have similar results to the 2090, and also for meat and bone meal we seem to have similar results from those that I just presented to you. We also added pig bristlets, also a pelleted product, and it seems to be results that are similar to the meat and bone meal. and we added a biostimulant as well. We have no significant effect as it looks from now at least, but it was a very good year, spring barley in Denmark, so maybe that's why. Maybe there's a tendency to a positive effect. On to the take-home message from here. We need to introduce nutrients in order to be more climate friendly and effective. And of course, we don't want to compromise the consumer credibility. And we think that recycling can be, it already is, but it can be a bigger part of the solution in Denmark at least. And then this digestate from household waste as a fertilizer is similar to pig slurry in many ways. It has a much lower amount of heavy metals, but it does contain plastic. Yeah. That's it. Thank you for listening.